In the deep and silent wilderness between the stars, where sunlight fades long before it reaches the dust of forgotten worlds, something ancient has entered our cosmic neighborhood. Not a machine crafted by human hands, not a wandering probe from Earth's restless imagination, but an object forged in the fires of another sun, older, colder, and far more enigmatic than anything humanity has ever seen drifting through the interstellar dark. Astronomers now call it 3I Atlas, the third confirmed interstellar traveler in human history. But from the very beginning, scientists realized this one is unlike anything that came before. Oumuamua arrived as a tiny shard, faint, quick, and perplexing. Borisov followed as a classic icy comet, behaving mostly as expected. But 3I Atlas? This visitor is massive, active, and so complex that it challenges the very models astronomers use to describe cosmic debris. This is the story of an object that, according to every statistical prediction, almost shouldn't exist. A visitor whose arrival has sparked debates across the world and raised questions most researchers hesitate to speak out loud. The first surprise was its size. When telescopes tracked its motion, scientists realized 3I Atlas spans almost 10 kilometers, making it 1,000 times more massive than Comet Borisov, over 1,000,000 times more massive than Oumuamua. In standard astrophysics, the interstellar medium should be populated by countless tiny shards, tiny fragments, and occasional mid-sized bodies. But a giant like this? According to the statistical models, humanity should have detected hundreds of small interstellar objects before ever discovering one this large. But that didn't happen. Instead, the third object we ever detected was a Titan. Was this luck? A cosmic accident? Or does its presence hint at something deeper, something our current models fail to understand? Scientists aren't sure, but they agree on one thing: 3I Atlas breaks the normal rules. Interstellar objects should arrive from random angles, drifting like cosmic seeds, scattered by the gravity of stars and the motion of the galaxy. But 3I Atlas didn't do that. Its trajectory aligns almost perfectly with the ecliptic plane, the thin, flat disk where all major planets in the solar system orbit. The probability of this happening by chance? Astronomers estimate less than 1 in 500. To many researchers, it looked as though the object entered our solar system through its front gate, choosing the one orientation that offers maximum interaction with planets. Coincidence? Possibly, but the coincidences were only beginning. Observations reveal that 3I Atlas rotates roughly once every 16 hours, a rate that is stable, predictable, and easy to measure. But here's the problem. If jets were naturally erupting from its surface, the rotation should smear them into arcs, distort their direction, or cause them to fan out. But it doesn't. Both amateur astronomers and major observatories have documented jets that maintain fixed orientation, extend hundreds of thousands of kilometers, remain stable for long periods, do not wobble or bend with rotation. Natural jets don't behave like this. Real cometary activity is messy, chaotic, constantly shifting as fresh pockets of ice heat up and collapse. But the jets of 3I Atlas seem controlled, consistent, and strangely resistant to rotational smearing. To some scientists, this is the biggest anomaly yet discovered. On November 19, 2025, NASA held a long-awaited press briefing. Expectations were immense. The Mars Reconnaissance orbiter, drifting in a unique vantage point, had captured new images, supposedly the clearest ever taken of an interstellar comet. But instead of clarity, what the world saw was a blurry, featureless glow, a motion-smeared sphere of light. NASA officials emphasized repeatedly, it's just a comet. Nothing unusual, nothing to be concerned about. But they avoided every major anomaly. They didn't mention the plume that seems to point forward. They didn't address the stable jets. they didn't invite the independent researchers who first identified the strange signatures. For many scientists outside the agency, the briefing felt like an attempt to calm the public more than an effort to explain the data. And beyond NASA, a different story was beginning to unfold. The most controversial visual feature of 3I Atlas is its forward-facing glow. In standard comet physics, jets and dust tails always push away from the sun due to solar radiation and wind. But in the HiRISE images, the extended glow around 3I Atlas points in the direction of the object's travel, not away from the sun, and appears to slightly lead the motion. A plume that points ahead instead of behind is extremely difficult to explain with natural processes. However, such a plume makes sense in one specific scenario: a directed emission, something used to illuminate hazards, detect dust, or clear a path in high-velocity travel. This is not proof, but it is a deeply uncomfortable anomaly. As 3I Atlas passed perihelion, mid-sized telescopes from around the world captured something NASA's instruments didn't show: long, thin, sideways linear features. They are not normal comet jets. Some stretch for hundreds of thousands of kilometers. Some appear narrower than any natural dust stream should be. Some look almost like traces, the kind left behind by smaller objects that drift or detach. Dr. Avi Loeb, the former head of Harvard's astronomy department, openly stated, "These features might represent the release of smaller bodies, whether natural fragments or something else. No one can explain them with full confidence. They remain one of the most unsettling signatures of the object." Some comets form anti-tails, narrow streaks that appear to point toward the sun because of perspective. But 3I Atlas has an anti-tail that is extremely narrow, highly collimated, over 1 million kilometers long, persistent for an unusually long time. Natural anti-tails typically spread and curve due to dust drift. But this one is so tight and controlled that it looks more like a beam than a plume. Either we are witnessing the most perfect anti-tail in history, or something far more directed. One of the strangest coincidences emerged when Loeb pointed out a chilling alignment. The famous 1977 WOW signal, one of the strongest unexplained radio bursts ever detected, originated from a point within 9 degrees of 3I Atlas's incoming direction. 9 degrees is large. It does not prove a connection, but it is intriguing. In 1977, 3I Atlas would have been roughly 3 light days from Earth, close enough that a powerful narrowband transmission could have reached us. We don't know if the two events are related, but the overlap is enough to warrant deeper investigation. In early November, the Meerkat radio array scanned the object. It detected 23,000 signals, all caused by human interference. No extraterrestrial transmissions. But the test covered only 1 frequency range, 1 time window, 1 orientation, 1 method of communication. A silent messenger is still a messenger, and the absence of a signal does not rule anything out. Across all observations, scientists have cataloged 12 major anomalies: a mass far too large, a suspiciously aligned trajectory, stable jets unaffected by rotation, a near-spherical shape, a plume pointing forward, straight, narrow lateral features, jet orientations that refuse to wobble, early brightness inconsistent with its distance, very low non-gravitational acceleration hydrogen distribution that resists natural explanation, directional overlap with the WOW signal, smaller objects that may be detaching or accompanying. Each anomaly has potential natural interpretations, but all 12 appearing together? That is where probability bends into discomfort. Everything now leads toward one moment, December 19, 2025. The day 3I Atlas makes its closest approach to Earth. Not dangerously close, but close enough for humanity's most powerful observatories to see the visitor with unprecedented clarity. James Webb will search for unusual heat signatures. Hubble will track jet behavior and possible fragments. Ground telescopes will monitor rotation and dust. Radio arrays will listen for narrow-band anomalies. According to Loeb, by mid-December, we should know whether the jets are natural sublimation or something engineered. The next few weeks may rewrite scientific history. If 3I Atlas is natural, we will witness the most detailed study of a giant interstellar comet in human history. We will learn how other solar systems forge and eject massive bodies. We will refine our models of chemistry, gravity, and the evolution of planetary systems. But if it is not natural, then humanity will confront the most important discovery since our ancestors first sparked fire. It would mean another civilization exists. They survived long enough for interstellar engineering. They send probes that endure for millennia. They may be surveying systems like ours. Even if the object is unmanned, its existence would prove interstellar propulsion is achievable. Long-duration probes can survive deep time. Our galaxy may be far more alive than we thought. These are not fantasies. They are the logical consequences of the anomalies we observe. The true mystery is not whether 3I Atlas is a spacecraft. The real question is this: why does this object display so many signatures that defy natural explanation, all at the same time? Coincidence? Possibly. Nature? Maybe. Or perhaps this visitor is part of something far older, far more capable, and far more deliberate than we imagine, conducting a silent survey of a civilization still taking its first steps into the cosmic dark. As December 19 draws near, one thing feels unavoidable. In the vast stillness of the universe, something is watching. And for the first time in history, we may finally be watching back.